Hello everyone, welcome back to my AIML series, myself Arnab Kundu. In today's video, we are going to learn Naïve Bayes Classifier. It's one of the simplest yet powerful machine learning algorithm. Okay, it is based on Bayes Theorem and makes a naive assumption that all the features are independent of each other. Okay, so go to the computer screen. Step by step I will discuss Naïve Bayes Classifier elaborately. So let's dive in. Hi everyone, welcome back to my channel Technical ArCoAn, myself Arnab Kundu. Today I will explore Naïve Bayes Classifier in machine learning. Okay, actually Naïve Bayes Classifier applies Bayes Theorem to predict most probable classes and assuming features are independent. Okay, despite the simple assumption, it works amazingly well in many real-world applications like text classification, sentiment analysis, spam detection, right? And also the Naïve Bayes Classifier is one of the supervised machine learning algorithm based on Bayes Theorem, right? Now I talk about what is Naïve Bayes Classifier. Naïve Bayes Classifier is a simple and powerful supervised machine learning algorithm based on Bayes Theorem. Actually, Bayes Theorem calculates the probability of an event based on prior knowledge of related conditions, right? Which assumes that all features are independent of each other. Okay, it is widely used for classification tasks, especially in text analysis like spam filtering and sentiment analysis. And today I will dive into the sentiment analysis problem. Okay, in machine learning, the Naïve Bayes Classifier uses Bayes Theorem as its foundation. It is called naive because it assumes all features are independent. Okay, and the Bayes Theorem stated in that way, the probability of the event A given event B is equal to the probability of the event B given A multiplied by the probability of the event A and divided by the probability of the event B. Okay, now we talk about why Naïve Bayes. Easy to implement and interpret, works well with large text data, and today I will use IMDB movie review dataset, and this dataset is one of the most popular dataset for sentiment analysis in natural language processing, simple NLP, right? Often used in email spam detection, product reviews and movie reviews. Okay, good baseline model before trying advanced machine learning. Okay, now we talk about key features and real life examples. Key features of Naïve Bayes Classifier based on Bayes Theorem with the naive assumption of feature independence, works well for categorical and text data, fast training and prediction compared to other classifiers, requires small amount of data to train, handles multi-class classification naturally. Okay, performs well even with high dimensional data like bag of words in NLP. Okay, applications which are used real world, spam email detection like spam versus not spam, sentiment analysis, positive negative reviews for an example, medical diagnosis, disease prediction from symptoms, document categorization, news classification, topic labeling. Okay, recommendation systems, predicting user preferences, text classification, language detection, intent recognition in chatbots. Okay, so go to the Google Colab. I will describe sentiment analysis problem using Naïve Bayes classification model step by step. Okay, now I am just within my Google Colab workspace and the code is already written. Some code is already executed because I have taken here IMDB movie review dataset, which contain here about 50,000 movie reviews, and this dataset is so much popular for sentiment analysis and the data taken from the internet movie review database. Okay, so that's why the number of samples is 50,000. So I take in training 25,000 and for testing take 25,000. So huge data. It will need near about 1 hour to execute the code. That's why some code I already executed, so result is already generated into there, and some code I will generate now. Okay, so this code is already written, and put the name of the file Naïve Bayes.ipynb. Okay, so this is the first part of the code where we actually import the drive, this module. Why? Because this IMDB dataset I just downloaded in my Google Drive. So this is the folder IMDB_data, and within that folder this particular file I just downloaded. This is actually one of the compressed archive file, and we extract the file also, and after extracting we get this particular folder ACLIMBD. Okay, and it contains test and training, these two different folders, and also this particular IMDB this dataset contains two outcomes for the category is concerned. One is positive and a negative. So on that basis it contains lots of files for the movie review is concerned. Just I open one file, so they are written some reviews of the file is concerned, review is already given into there. So in that way total 50,000 data is there present within this particular this folder is concerned. So this dataset is concerned contain 50,000 dataset. So we just need to be mount this path which is actually provided within my Google Drive. So that's why we need to import this drive and we mount it. So by default the mount drive is content_drive and my folder name is IMDB_data. I just show you, this is the IMDB_data which is in my home. Okay, so that's why we need this particular section of the code. After executing that, result mounted at /content/drive, and then what happened, we already told this is actually the compressed archive file which I already downloaded from the internet. So I have already extracted it, because for extracting it takes more times. Okay, if you don't extract, so extract it using this particular code. So that's why what happened, it's already extracted, so extract only once, don't need to every time. So I already extracted the file, that's why we get this two different folder, test and train
for 25,000
testing,
for 25,000
training data. Okay, and also two categories, positive, negative. And after that this is the code, means this is the steps of the machine learning task is concerned. So first step we already know, this import the modules, sklearn need for the machine learning tasks, seaborn, matplotlib and pyplot need for the visualization of the data, and joblib is the new module which is used for loading and saving the model, because we already told that this model trained lots of data, needs near about 1 hour for execution. That's why we save the model and after that we load it for our requirement for the prediction is concerned. Okay, so here I don't use the train_test_split this function, because what happened, the IMDB this particular dataset is already predefined, speed is there, 50% for training, 50% for testing, means 25,000 data goes for the training and 25,000 data goes for the testing. So that's why we just took the data from there into these two categories. Pos means positive, neg means negative, in that way train_data, test_data, and these are the different paths of this particular dataset is concerned. And then already told 25,000 reviews for training, and we already know x_train and y_train, input features for training and output for the training, and same way x_test, unseen input data for testing and their predicted output values for the testing. So in that way we just pick up the data from there and then we print the training samples and the testing sample, so output should be 25,000. Okay, then we build the pipeline, means the bitration and the NB, and here we use for that, for the pipeline is concerned, use
count
vectorizer. It converts the text to token counts, and TF IDF transformers is transforms counts TF IDF. Actually what happened now, build a pipeline that first converts text into token counts, okay, and then applies this TF IDF transformation. So these take more times actually, okay. So TF is actually the term frequency, how often a word appears in a document, and IDF, inverse document frequency, means how rare a word is across all documents, okay. And after that we create a
Naïve
Bayes classifier multinomial NB, okay. Then we finally train the
Naïve Bayes
classifier using this fit method, and we send the training dataset as argument, okay. So input features for the training and output values for the training. Then we predict and evaluate the model. So for the prediction we use here predict, this particular method, and we send as an argument what unseen input data for testing, and from there we get some predicted output. And after that we already know for evaluation, here we use, for classification model is concerned,
confusion underscore matrix,
classification underscore report, and accuracy underscore score, these functions. And after that we send the arguments, one is the true output and other is the predicted output for each and every function is concerned, and from there we get the value and we evaluate the model, how model performs, how model perform well, okay. And then we visualize, and here we use the heat map. So we plot the confusion matrix using heat map, and the row represents the actual classes. Already know the class is the two, one is the positive review as a negative review. So rows represent the actual classes and the columns represent the predicted classes, okay. And the negative and positive labels make it clear how well our Naïve Bayes model is classifying the IMDB reviews. And for that case we already know our total dataset contains 50,000 data, and in testing purpose we are using half, means 25,000 data, okay. So it's a massive data, it needs lots of time to evaluate and generate the result, okay. And then after that the title is that Naïve Bayes confusion matrix IMDB sentiment analysis is concerned, because we use here IMDB dataset, and X level predicted and Y level is actual, okay. Now the model saved within the Google Drive, because we saved the model, already told, we already given job leave this module, and one of the method used here dump. So within the Google Drive we save it, means we save the model within the Google Drive using this
file
sentiment underscore nv underscore model dot pkl. So just see, this file is already there, this is the file name sentiment underscore nv underscore model dot pkl, okay. And now this code is already executed, and the result is that already told, training samples 25,000, testing samples 25,000, and this is the confusion matrix. So the confusion matrix is given in that way, these are the rows and these are the columns. So row means these are the true negative, true positive, this is a predicted negative, predicted positive. So 10,979 samples from the true negative are correctly predicted as negative, and 9,769 samples from the true positive are correctly predicted as positive, okay. And rest of the two are some misclassification is there. So overall the model perform well, and then the classification report is there, the precision, recall, F1 score support, and the accuracy is 0.82992, that means near about 83%. So model works perfectly, we can say. This is the visualization in the form of 2D graph, and this actually the heat map of the confusion matrix. So the title is Naïve Bayes confusion matrix IMDB sentiment analysis is concerned. So this is the row, so this is the true negative, true positive, predicted negative, predicted positive. So same thing, whatever the confusion matrix shows here as a result, just put in this graph format, okay. Now what happened, now we predict something from there, okay. We give some
movie review
from as input is concerned, and it will predict on that basis it positive or negative. So in that case, same way we at first load the model. So in that case, because I already told, I already save the model. Now we need to load. We again mount the Google Drive. So that's why you click that button and it will mount the particular Google Drive is concerned. So it will take some time for that cases, and on that basis we connect the Google Drive, then just connect with my account is concerned. So it will take some times and do these steps should be. After that it will written that mounted. When this is mounted, then we execute this code. Okay, so this is already mounted, and the already is given is that some line is given for the movie review is concerned, and this is given as an input. I really enjoyed this movie. The story was gripping and the acting was top notch. So it will like a positive review, right? So the prediction should be the positive. So just see, so just click on this button. So it will execute the code, because at first it will load the model already saved in my Google Drive. The file name is sentiment_nb_model.pkl. okay, it will take some times, near about 2 minutes, because need the load of the model, and then it will predict it's a positive or negative depending on whatever the new review given here. Okay, so I have already trained the model, 25,000 training data already given and 25,000 data for testing, and on that basis we put some unseen, totally unseen, which is not present within this data set in IMDB Dataset is concerned, and on that basis it will generate the predictions, means the classify, means the class
Is a positive or a negative? Okay.
just see the result is already generated. Review is, I really enjoyed this movie, the story was gripping and acting was top notch. So predicted sentiment is positive. Okay, now we change some different review, and the review is somehow negative. So this is a given, the movie was boring and too long. So that means the prediction should be negative. So again run it. So just see, yes, review, the movie was boring and too long.
Predicted sentiment is negative. Okay.
I hope you have understood how Naïve Bayes Classifier classify the sentiment and how it analyze it, because we already taken the Naïve Bayes Classifier model and IMDB dataset we already taken. 50,000 data is there, huge, is a massive. So that's why whatever the input we are given, on that basis whatever the pattern it learn, on that basis is predict and classify into two categories, positive and negative review is concerned. I hope you have understood today's topic. If you have some doubts for today's video is concerned, just write in the comment section. I will try to solve this problem. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical ArCoAn for more videos. So today up to this. Thank you and bye bye.